My name is Arm McCarthy.
Hi, my name is Arm McCarthy. This is my IoT assignment 2, NodeJS and BLE. The basic idea of this assignment is to communicate from the microbit to a broker and the broker to a microbit. This is the basic brief that we were given. It's reworded and colorized in a way that you can better understand what the assignment is in basic terms. So, the goal of this assignment is to transmit accelerometer x-axis data from the microbit to the Raspberry Pi through Bluetooth, and that data from the Pi to the MQTT broker through the internet. Basically, the idea is that through Bluetooth we send information to the Pi, and through the internet we send information from the Pi to a broker. Part 2 of this assignment is to send a message from the broker to the Raspberry Pi, which sends the message to the microbit, which sets off LEDs. It's basically just the reverse order. Now, the specific assignment is not necessarily the accelerometer, because I know other people have used the CO2 sensor. Unfortunately, mine just decided not to work, even though it worked in the last assignment. However, I used my accelerometer because it worked well and shows the basic principles of what's needed. So this is how I subscribe to a topic. This is how we get data from the broker to the Pi to the microbit. Basically, it does connection callback, and this connection callback, or MQTT client.on connect connection callback, and the callback is basically subscribing to the topic that we want to subscribe to. Very simple stuff, and the console.log connected to the cloud MQTT broker basically just tells the user, yeah, we're connected, no problems here. That's the only reason to print to the console is for the user actually looking at the computer at the time. So this is how we publish to a topic. Now this is a function, notifyCar.on. When the value is changed, goes into a buffer, which prints to the screen. This does not necessarily have to happen. Again, you don't have to necessarily print to the screen for this to work, but just to inform the user looking in front of you, looking at the console window, that we're getting the information. Characteristic value is the C value. C value is the value of the accelerometer. Two-string hex. Yeah, it's just printing it out. That's all that's relevant there. But to actually publish it to the subject that we want to publish to, it's MQTT client.publish topic to publish to. Again, that's just the topic we want to publish to. This is just the characteristic value is. This is also publishing to the client, just to make the data more readable rather than just random hex values. Yeah, C value, two-string hex. That's the actual data from the accelerometer, or from the microbit, the accelerometer value going to the broker, and then it does the publish callback, which informs us of errors or anything like that. Reading the values from the microbit. Now, this slide doesn't really give you the full context of what's going on. I put in as much as I can, but basically, you can see from the top section bit of the code, that is the service. That's just basically extracting the service that we want, the service UUID that we've identified previously, and making sure that that's the service that we're going to get information from. The next one, notify car, await primary notify service .get characteristic, notify characteristic of interest UUID. Basically, all I'm saying there is that we're getting the UUID, the identifier of the characteristic that we want to extract data from, which is defined up at the top of the code as notify characteristic of interest UUID. And then finally, we get the value from the microbit, the accelerometer value from the microbit, by doing await notify car.read value reads the value. I forgot to record this in the actual main presentation, but to write the message to the microbit, this was the section of code that was used. This bit of code was in the main rather than outside of the main, due to the notify car not being defined outside the main, and it just made life a lot easier. And yeah, it just writes the value hello world to the microbit. There's no sense to write hello world, and actually you can just put in message there. However, I feel it saves complexity. It's easier to look at. I feel just hello world, you know that's useless. And I know if I wanted to change it in the future, I just change it. Try the rest of the presentation. Turning on the LEDs, I unfortunately don't have the code. Laptop's over there with Linux on it. Can't get Zephyr because of the distribution, updated distribution of Ubuntu I'm on. I don't know. You can ask Pierce Lowe about that. I can't get it working, and unfortunately I just can't get the code in front of me. But all I'm really doing is the microbit, it sees that there's been a write from the Raspberry Pi to the microbit, just sets off all the LEDs, and that's basically all that's happening. This is just a basic animation I did in Adobe Animate to very basically illustrate what's going on. The message is being sent over internet from the broker to the Pi sending that information through Bluetooth to the microbit, and yeah, and it sets off LEDs. I'd like to now show you the live presentation of my whole setup working. I hope you enjoy that. Hi, my name is Oren McCarthy, and this is my assignment 2 video, or at least the live action part of it. So we're just going to start running the JavaScript file. Now, sorry for the camera moving here. It's just in a bit of an awkward situation. Okay, so I'm about to run the code. I'd like to note that my microbit there is not on. So, you know, there's no trickery going to be going on, I guess. So we're about to run the code, but before I run the code, I'd like to make note that here on the HiveMQ broker, we are subscribed to SpiceBag, and you'll see from the code there that we are subscribed to SpiceBag, or we're going to be publishing to SpiceBag. And yeah, so let's run this code. Looking at the broker, it's connected to the device. The device is called Shira 5.1 Lamau XDDD. And that's the MAC address of the device. So it's connected to the device, and it's printing the x-axis accelerometer values. Notice that the values are actually not changing. I'm gonna be dead honest with you. I'm not sure how to do that. Like I don't have much access to Zephyr at home, and the labs are very hard to get into at the minute. Anyway, we're going to receive data from the topic accelerometer, and the idea is that it will cause the LEDs to go off. So that's the message there. Bunch of gibberish, it doesn't matter. Look at the microbit again, no lights are on. We're gonna press publish in a second. 3, 2, 1. Publish, LEDs are on. So here are some possible innovations that can be done. None of these are actually implemented in my code. Unfortunately, I don't have the time. A lot of debugging that has to be done, and other assignments, you know yourself. Either way, one that I thought of was exporting the message to the LEDs on the actual microbit. Maybe if the message was hello world, the LEDs would light up a H, then an E, then an L, then an L, you know yourself. It could do anything like that with the message that's being sent in. Setting up a password and quality of service. The password is for security and quality of service. You might not need the best quality of service depending on the application, if it's not essential or anything like that. So you can set this up, and there's lots of documentation on how to do it. Debugging, don't really have a lot of time, so unfortunately it's not implemented. And finally, one that I know that a lot of people aim to do with the CO2 sensors, which is changing threshold values on the CO2, the parts per million of CO2 that would cause the LEDs to light. I'd like to thank you very much for watching.